It shouldn't be surprising that parametric equations are perfect for describing circular motion using the sine and cosine functions, because that's how sine and cosine were originally defined. If you remember way back to your triangle trig, you know that the sine of an angle tells you the length of the opposite side divided by the length of the hypotenuse, and the cosine tells you the length of the adjacent side to the angle divided by the length of the hypotenuse. So if we imagine a circle of radius 1 called the unit circle, any point on the circumference of that circle is going to have a distance of 1 to the origin. So what that means is that the hypotenuse is always 1. So what that means for us is that the sine of an angle is just going to tell us the length of the opposite side. So here's the angle, here's the opposite side, so that's the same as the y position. The cosine is just going to tell us the length of the adjacent side, again, because the hypotenuse is 1. So the adjacent side is the same thing as the x position of the point on the unit circle. Oops. So that has immediately given us a parametric description. If you just imagine that the angle is labeled t and changes as a function of time. So if we're going to write it a little bit more properly, we've got that the horizontal position as a function of time is the cosine of the time, and the vertical position as a function of time is the sine of the time. So let's see what it all looks like when the angle is actually changing as a function of time. Here you see the horizontal position as it changes with time, both in the moving circle and the graph of just horizontal position with time. We're going to do it one more time. So you can see that when the graph starts, the horizontal position is at 1 and it decreases to 0 right now. Now the horizontal position approaches -1. Now you can see the horizontal position approaching 0 again. And you can see the horizontal position approaching 1 again. In this example, you see both the x position as a function of time and the y position as a function of time, and how those look as the point moves around the circle. So try and look at only one graph at a time, and look and see how the output from the function describes the position of the point moving around the circle in either x or y. Feel free to pause the animation, feel free to play it slower, feel free to repeat it, but make sure that you understand how all of these graphs are related to each other.